Hello. In this video we're going to look at a routine, an algorithm for sorting things called the bubble sort routine. Now in your programs, your analysis programs, you've very probably got a set of letters, you've probably got A up to Z. I'm only going to do A up to E just for the purposes of this video, and associated with those you're going to have the number of times that that letter occurs in the message that you're trying to decode. So in this case I've got 1A, 5 B's and so on. Now I want to sort these out so that the most frequently occurring letter D is going to appear at the beginning along with its count, and then the second most frequently occurring letter, which is B, is going to appear here, and so on and so on and so on. So I'm going to have all of the letters sorted in order of frequency within our message. So we need our two arrays, one that's got the letters, one that's got the counts for each letter, and obviously they correspond, the elements correspond, so A5 and $5 both relate to E and the number of E's that are in the message. I also need to set up a couple of variables, one called temp $, where I'm going to temporarily store some text, and one called temp, which I'm going to temporarily store these numbers. And I'm also going to have a switch flag, which is going to tell me that on a particular circuit through my my algorithm, a particular loop through the algorithm, whether or not I've made any swaps and changed anything around. And if I get to the point where I've compared everything in a particular loop and not made any changes, then I know everything's in the right order, so I can finish my loop. Now I'm not going to tell you exactly how to program this because I want you to work that out for yourselves, but I'm going to show you through the algorithm and how it works now. So let's bring in a little pointer here. So here's my pointer. I'm going to point at the first variable, and because I've got 5 elements, I'm going to compare 1 with 2, 2 with 3, 3 with 4, and 4 with 5. 5 elements requires 4 comparisons. So when you're setting up your loops in your program, you're only going to have to loop 1 fewer times than the number of letters you've got. So for my first comparison then, let's compare 1 with 5. Now obviously 1 is smaller than 5. I would like the 5 to be to the left of the 1. So I'm going to do a swap. So let's pick up the 5, and because it's a number, I'm going to move it into the temporary number variable. Then I'm going to put the 1 where the 5 was, and I'm going to put the 5 back where the 1 was. So that's great. So I've swapped over the 1 and the 5, but now I need to swap over the letters as well. So same process, put the B into the string variable, temporary, put the A where the B was, and then put the B back where the A was. Now it's really important that we use these temporary variables, because if I try to put the value of B into $1, that would overwrite whatever is in there. So this is why I need to copy the thing out first, then copy the value across, and then copy the thing back again. Now because I've made a swap, I need to set a little switch here to say yes, I've done a swap this time round. Now let's move on. So we move our pointer on to the next variable. Right, 1 and 2. Now they need swapping again. So I'm going to put the 2 into temporary variable. I'm going to move the 1 over to the right hand side, and I'm going to put the 2 back. Put the 2 back into here. Likewise, I'm going to put the C into temporary area. I'm going to move the A where the C was, and then bring the C back in here. Notice how, by repeating the switch above, if we do a switch here, we have to do a switch here. We're keeping the letters with their corresponding frequency counts. So we've done that. Because we've done a switch, I need to set the switch flag to 1. The fact that it's already at 1 is neither here nor there. I still need to set it to 1. And let's move on. Now we're comparing 1 with 9. Obviously they need changing again. So let's put the 9 over here. Put the 1 into the next slot. Bring the 9 back in. And then do the same with the letters. So move the letter around. Put the letter over here. And put the letter D back again. And set the flag to 1 to say we've done the switch. Now we move the arrow on and we're comparing 4 with 5, and obviously I need to swap these two as well. So Same thing happens, bring the 2 over, move the 1 across, bring the 2 back in, oops, and do the same with the letters. Now this was a kind of a fairly extreme case because I've had to swap every single time. But as a result of doing this, let's finish this off here, as a result of doing this, 1 is now where it needs to be, okay, and the A is where it needs to be, the frequency of 1. So the lowest occurring letter has bubbled, this is where the name bubble sort comes from, has bubbled its way to the end of the list. So next time round, instead of doing 4 comparisons, I know that this last box over here is definitely the least frequently occurring letter. I'm only going to need to do 3 comparisons on the 4 that I've got left. Right, I've got to the end of this section of the loop, so what I've got to do is just check my switch. I have made some changes, so I do need to go back and check again. So before I go back, I'm just going to set that back to 0, so we're starting a new loop, move my pointer right back to the very beginning, and we just start the whole thing again. We're not going to change those last 2 this time around. We're not even going to bother checking those because we know that the lowest frequency letter has already bubbled its way to the end. Okay, so we're back at the beginning, compare 5 with 2. Oh, we don't need to make a change because 5 is already bigger than 2. So now we move on. Is 2 bigger than 9? No, it's not. So I need to do a change. So bring the 9 down to the temporary area, move the 2 across, oops, and bring the 9 back in again. Swap the letters over as well. Move the C across, bring the D back in, and again remember, because we've done a switch, we need to set that to 1 to say that we've done a switch. Now we move on to the next part of the loop, and we're comparing 2 with 2. Well, 2 is equal to 2, we don't need to do a switch there. So we've got to the end of the loop, we don't need to check that last one again. We know that that's in the right order. So I can do a couple of things. First, I can say, well, I've reached the end of the loop. I've got a 1, so I'm going to have to move my pointer back because I did switch something, so I still need to check and see that everything's in the right order. And next time around my loop, I'm not going to have to check element 4 because I know that's the next smallest one. Now, when I start my loop, I need to set the switch back to 0, and we start all over again. Do I need to swap these 2? Yes, I do, because 9 is bigger than 5. So let's swap that one here, swap this one over here. Done a lot of swapping so far. Then bring this one back in. Bring the D out. Move the B across. Bring the D back in. And set my switch flag to 1 because I have made a change. Now I need to move the pointer along again. Is 5 bigger than 2? Yes, it is, so everything's okay. So I've reached the end of my loop. Switch flag is still set to 1, so I'm going to have to go back and do another circuit. So move my pointer back to the beginning, set my switch to 0, and this time round we're not going to have to check that last character there because we've already checked it. Now I've got to make one comparison. I've got 2 things left. Is the 9 bigger than the 5? Yes, it is. So I don't need to do any swapping, so I don't need to set the switch flag, and as it happens I don't need to move the pointer on anymore because I know that the later letters are going to be in order anyway. So a number of things have occurred here. 1, I've actually reached the end of my circuit, but 2, because the switch flag was set to 0, I would know that everything was in the right order. I went right through a sweep and I didn't have to make any changes, so everything is in the right order. So now let's just move this out of the way. Let's move this out of the way. I know everything's in the right order. D was the most frequently occurring letter with 9 occurrences. B was the next most commonly occurring letter, C, and so on. I could just simply print out all the letters D, B, C, E, A in that order just by going through my array of letter names.